the problem? So why am I up there pointing right here? We're talking about the rate of change of something, or the rate at which something is increasing or decreasing. Are we talking about d box, dv, dt, dy, dx, dx, dt, d something, dt or dx, right? Okay. So why did the entire packet start off with translate? Because you are going to read problems like this. Last year there was an escalator problem. Everybody hated. 2 years ago there was a banana problem. Everybody hated. 3 years ago there was, last year in BC there was a plankton problem. I know that because I can see the memes as you guys are taking FRQs from all the kids complaining from the East Coast who just finished their FRQs. So I'm like, oh, cool. There was a banana display this year. Great. Why am I never worried whenever I see something like plankton or bananas or what else? Biscuits and tea or gravel, or why should I not be worried? I never am. I'm just like, oh, kids. They're going to throw at you a word problem, or 2, or 6, or 12, or 34. I don't care. And they try to make it different. They try to make it new. So they're going to throw at you maybe apples this year instead of bananas. Sure, they're going to throw at you some other sort of something that's produced besides gravel and besides rain in a silo, or whatever else they want to give you. Could there be turtles instead of snails and ants? I don't know, and I don't care, because behind all of it, isn't there just very solid, basic calculus concepts out there? Who cares about what they give you? Unless you're like, I can make a meme from that. Okay, cool. Go team. Just complain about your AP test, but don't go saying, I wasn't ready for grain. I don't care about the grain, and neither should you. Why? Whatever it is that's increasing or decreasing, whatever it is that has a rate of change, I can still mathematically express. Now this one's easy because it's area. Wouldn't you guys say, or didn't you say, dA dt is equal to positive 6? Right? Hopefully. The area of a circle is increasing. The rate of area is d who dt, dA dt. Increasing means a positive rate, so positive 6. But when this one said decreasing, what did you guys hopefully set dV dt equal to? Negative 2. But down here, when it says translate into words, it says, okay, do you really know what this means? Like if we ask you for this and then ask you to explain it on an FRQ, its meaning in the context of the problem? Well, they gave you easy ones because they're geometry. Guys, shouldn't you have said something about, oh, it's the rate of change of volume with respect to time being or is negative 28. Okay, that's great. AP speak would much rather say something about, oh, the volume is decreasing at a rate of 28. Why is it okay to say decreasing in a positive number? It's definitely not okay to say decreasing of the negative number because that's a double negative which cancels out. Anyway, keep an eye on units. There's a lot of that sort of stuff, but long story short, you guys had lots of words problems. Let's see where you got stuck. Ready, set, go. Multiple choice. 5. 7. 3, 2. Okay, let me start with that. No, actually, period 1 really wanted one. I think that was the one I wanted. Number 2, I'm going to the ones I heard. 2, 3, 5, and 7, and we'll see if we have time for any more. We might just go to FRQs. Number 2, a beach ball is deflating at a constant rate of, first of all, by seeing the word something. I do what I can with what I've been given. Hey, that's what God calls all of us, right? Do what we can with what we've been given. Why am I about to write dV dt if this will ever start with deflating? It's volume. And what else can tell us that? Hey guys, isn't cubic always a volume measurement? Squared is an area, single is some sort of length that I know. So, deflating. Why am I going to do negative 10? When the volume of the ball is V equals 256 all over 3 pi, what is the rate of change of the surface? And they tell me S is surface area. Now I have formulas, so wouldn't some of us just think of taking derivatives right away? Wait, why derivatives? Well, didn't you see the word rate used over and over again? How do we deal with rates if we don't have rates? Now, period 1, I did it in a way where I said, what do you guys see? V's and S's. Let's get rid of R. And that was our objective, to get rid of R, and the math got weird. just because I'm doing 2 different videos today, why don't we go the other direction? Why don't we say we need derivatives? Let's take derivatives. So what if we took derivatives of this guy? Wouldn't we get ds dt is equal to 4 pi is a constant, bring down the 2, 8 pi r dr dt? You guys agree? Couldn't I also take this dude's derivative? Because I have a dv dt, it must have come from somewhere. dv dt is equal to, bring down the 3, 4 pi r squared dr dt. So what can I plug in, cool kids? I need to find this dude. Okay, I can find dr dt. Can't I find dr dt technically by getting him by himself over here, by dividing or multiplying by the reciprocal? This dude? You guys agree? If I can go ahead and rearrange this dude to get dr dt, let's go ahead and go plug him in, because I don't see any dr dt's that have been given to me. So if I can get rid of them, I will. And I end up with, okay, ds dt is equal to, I have 8 pi r times 1 over, oh man, this is so much easier than the other one, dv dt. Doesn't the 8 pi reduce to the 4 pi? Doesn't the r reduce to the r squared? So what I have left is 1 over, and it's so much easier. R dv dt is equal to ds dt. Alright, time to plug and chug. One more time. I know he's -10. But wait a minute. Don't we usually get the R or whoever we're missing by the clue? But the clue, oh wait, what's volume equal to? Can't I get my R? Cannot reduce, thank you. Boop. Ironically, I got it right doing it the hard way. Okay. Can I set volume equal to what volume equals? As far as, can I plug in the volume to the formula and solve for R? So I could divide by pi, that goes away. I could divide by thirds, that goes away. I could divide by 4, which ends up with 64 is equal to r cubed. R is equal to, I believe, 4.
Attention warriors, this is Mr. Gavin with the middle school election results. We had 3 clear winners, and we had 2 races that are going to be in a runoff tomorrow. I'll announce the winners first. Winning Vice President, Caleb Gordon. Winning Secretary, Kingston Kim. Winning Chaplain, Ryan Krikorian. For President, in English class, 6th and 7th graders have a runoff to vote for Dylan and Natalia. For Public Relations,
2, I think it was 3, then 5, then 7. Does that sound about right? Yeah. Okay, so, number 3.
Oh, I don't need 7.
Okay, cool. Still 3 and 5? You still need 7. Number 3, the height of grain in a cylindrical silo. What's a silo? I don't care. It's a cylindrical. Now, technically there's a farm, and then there's a and then they put the grain in. This is the tall tower next to the farm. Go travel to the Midwest. Anyway, so coming back. Or just looking to make sure we're farm. So sad. We have so much information at our fingertips.
Concrete one, John.
So what do we know? Whatever's inside the cylinder is increasing. Oh. The height is in, oh, isn't that a dH/dt? Increasing at a rate of 4. If you want to, sure, feet per minute. At what rate is the volume, dV dt, changing such that the radius is 10? Oh, and they gave me a formula. V equals pi r squared h. Don't I have to take a derivative? Yeah. How many of you, your brains would say, derive first? How many guys would say, I want to get rid of h first? R first? Okay, so what would we derive? Derivative of v is dv dt. True. Why am I about to do a pi and a big old bracket with a plus? Product r squared times. So I'm going to have second d first, which has a dr dt, plus first d second, which is dh dt. Don't I have way more than the stuff that they gave me, guys? I need to plug in. I have way more than they gave me. Well, this stinks. He's the only one that's allowed to be unknown because he's the dude I'm finding. Well, what do I know?
10.
10 is R. Okay, well that's something, right? So we'll do pi, and then we'll say, I don't know who you are, but I know that R is 10. Okay, cool. So that's going to be 20, right? Don't I know D? I don't know D or DT. Well, that stinks. Plus, oh, R is 10. Whew, that's 100. And I know DHDT is 4. And now I'm still missing stuff. Well, so then we go back and say, what do we miss? The heavy grain, a cylindrical silo, is increasing at a rate of great. At what volume? At what rate, sorry. Is the volume of grain in the cylinder increasing if the radius of the silo is 10 feet? Hold on. The radius is 10 feet. The radius is... What's not changing?
Radius.
Oh! So if the radius isn't changing, then who's DRDT?
0.
It's not changing. So its rate of change is 0. The radius is not changing. Who is changing? Only this guy. No. So we're done. It's 400 pi. Dun, 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 dun.
That was so much effort.
You just went for it? Whoo! Lucky duck. When do we get to say that a rate is 0? If it is unchanging. Like the length of a ladder as it falls. Unless it's breaking, it's not changing. It's the same length. Okay. 2, then 3, then 5, then 7. 5. Oh, this nice lady asked me this one at lunch, so it's fresh in my mind. You have 2 bikes on a perpendicular road, both leaving an intersection. A is going this way. So we can call maybe his distance x. B is going that way. We can call his distance, I don't know why. And then we're talking about the distance between them, right? Cool kids, what formula relates all that? X and Y and D. Yeah, because it's perpendicular, right? But hold on, we have movement, we have change. So can't we say x squared plus y squared is d squared? Basic, right? The stuff's changing, derived, right? With respect to time. So what's going to happen if we take derivatives? Okay, hold on. 2x times, don't forget your u prime. Dx dt plus 2y dy dt equals 2d d dt. Oops, we have lots of these. What do we do? Wait. We're okay. This is changing, it's a variable. This is changing, it's a variable. This is changing, it's a variable. I just took the Pythagorean and took the derivative, right? Wait, what are our such stats? What do we know? Bike A is leaving. Oh, I know dxdt is 2. What else do I know? Bike B is leaving the intersection at, dy dt is 3. I just made the distance x for A and the distance y for B. Is that okay? I wanted to let them know, hey, A bike. This is how far you can. So I can go ahead and plug in dx dt is 2. dy dt is 3. Sorry, that's a 3. And then, oh no! Wait, who am I allowed to keep? How fast is the distance? That's a rate of distance, right guys? I'm allowed to keep him. He's the one dude that I'm not supposed to know and I'm supposed to find. Oh no. What's my clue about x and y and d? Okay, you gotta use some good old common sense. Feet per second. Feet per second. 5 seconds.
15.
Nothing else to build a bridge, but John's totally right. If he's thinking, hey, this dude's going 3 feet per second for 5 seconds, has gone 15 feet. Oh, why is 15? The dude is going 2 feet per second for 5 seconds. Ah, how far has he gone? Build a bridge. Don't I want those to cancel? Can't I just multiply and say, oh, 20 feet. Sorry, it wasn't for 10 seconds, it was for 5 seconds, right? he's gone 10. Oh, but how about 10? Wait, it's a right triangle. So if I know this guy is 10 and this guy is 15, how do I find that guy? Good old-fashioned, oh, hey, 10 squared is 100 and 15 squared is 225, and D is going to be the square root of that. Oh, that's $3.25. Yeah, $3.25. Isn't that 4 and 4 and 4? 12 quarters and one more?
I would not have thought of
Actually, really smart. Think about quarters. Whenever you have 25, how many 25s go in? Anyway, 13 quarters go in, 13 25s come in, so I have 5 through 13. Oh, that's why there's 13s. Anyway, we end up with 2 times 2 is 4, and 10 is 40, plus 2 and 3 is 6, and 6 and 15. 2 15s make 30. I have 3 of those, which would be 90, equals 10 rad. You guys don't need me, you just need to do some math. What's that, 130? Divided by 10 is 13. 13 divided by root 13 is going to be, rationalize it, root 13. Okay, 7. Just going to look at it quick. Oh, where am I? I don't even know. There you go. Okay. Number 7. I see graphing calculator. Ooh, the volume of a spherical balloon is increasing at a rate of, isn't that dV, kids? Volume increasing rate. So dV dt is 0.78. Is that plugged in? At the instant when the radius is 3.2 inches, the radius is increasing at a rate of, I don't know, let's find some derivatives. Isn't dV dt equal to, keep the constant, derive the other dude. All I have to do is plug in my dV dt to be 0.78. Simplifies some things. The RDT I don't know, and it's totally okay. I'm about to find them, and they told me on. Booyah! Calculator, divide, done. As long as everything matches up, and this guy is inches per minute and inches, got it, per minute. Everything matches. Okay. FRQs real quick. I know there are more multiple choice, but for right now, FRQs, anything real fast for you to do that? Going once, going twice, must not be any burning questions. 4C.
Oh no.
Oh no, you're good. Mock AP, we're getting right there. Sorry.
No, just for this. And then FOR. Never mind. Just see.
Number 1. Got it. No, I'm tracking. I just didn't know which FRQs still. I got it. We're good. Okay. FRQ number 1. Getting down to C. But first of all, are we translating okay, guys? Radius, increasing rate. Isn't that dRdt? Isn't this the radius? And isn't that the radius? Ooh. That's not the radius. It doesn't go to the edge of the circle. That's the radius. Why am I saying that? Well, don't squares depend on s's, whereas circles depend on r's? But don't I know that this part of the square is 2r? Anyway, part C says, when the radius of the circle is 5 root 2 centimeters, so when the radius is 5 root 2 centimeters, what is the rate of change in the shaded area, dA dt, where A is the stuff outside the square, so pi r squared inside the circle, but outside the square. So the circle area minus the square area. Now, oops, sorry, wrong one. The circle area minus the square area. Well, we have to kind of figure out our areas for this. I'm just, for sake of time and for sake of space, I'm coming up here. Area of the circle is pi r squared. Got it. Area of the square is side squared. Got it. So circle minus square would be everything here, everything here, which is what they're asking for. We could go ahead and say, I'm doing that, sorry. I could take a derivative, because you guys kept saying you just think of taking derivatives all day long, which is kind of good and kind of scary. But 2 pi r dr dt minus 2s ds dt The problem is, don't I only have R to plug in? Oh, wait, up above, didn't they also give me dRdt?
Yes.
So I do know 2 pi 5 rad 2 times 0.8 minus, now I'm a little bit stuck. If the circle's changing, the square is changing too. So I know dRdt, but how does R and S relate? Well, long story short, do you guys see this as really another Pythagorean theorem where I could say something to the effect of s squared plus s squared is equal to psi squared, which would be 2r. So I can say 2s squared is equal to 4r squared. So I can say, how do we do that? We have dRdt. We want to get rid of s. S is equal to the square root of 2r squared, which s is equal to the square root of 2 times r. I can get a relationship between s and r using a quick little right triangle and Pythagorean theorem. So I can come down here and say, okay, well, if r is equal to 5 rad 2 and s is equal to rad 2 times r, well, wouldn't rad 2 times rad 2 be 2, and 2 times 5 is 10? Oh, so I can plug in s is 10. Ah, but I need ds dt. That's okay. Don't you have something up here that says if you know dr dt, you can find ds dt? Maybe you have to take derivatives multiple times because you don't think ahead. You just go taking derivatives. Well, you're going to have to come back to this relationship and somehow ask for help in your derivatives. But I can go ahead and plug that in. Choop, choop. And so ds dt, I also know. I ran out of room, sorry, which is going to be 0.8 times rad 2. Whew. There you go. No, it's not pretty, but there you go. There's your derivative of your area, or the rate at which the area is changing with respect to time when r equals 5 rad 2. I'm sure they have it in a much prettier form, but that's the long story short. We're going to the mock AP 3 through 6. I know we might not have gone over all of your LTF questions, but I want to get to the mock AP because that's your immediately for tomorrow. Oh, sorry, I made this forever. You still taking it? Oh, Gavin's. Okay, 3 through 6. You just gotta tell me Wednesday or Saturday what you want clarification on. I'm not walking all the way through because someone already did that for you. Someone in BC making a video. It's not their favorite thing in the world. As you guys are peeking over 3 through 6, I'm gonna go ahead and pass back your after spring break forever quiz, just because I want you guys to peek really quickly if there's something that you thought you had solid that you might have made a little mistake on. When you hear your name, come on down. Lainey, Abby, Kyrie, Lorenzo. Just check it. Kevin, Hannah. Just check it. Look over the mistakes. There were technically 31 points possible, so there were lots of bonus extra points. So your score, subtract 4, and that's kind of what maybe you deserve a little more. Caroline, Joe, Gavin, Jaden, John, Victor, Dean, Mel, Jacob, Jack. Oh. Next lesson, collect them back in just 1 second. So peek over it, see if there's any particular cards that you should look at. Take a special note of it, collect it back in just 1 second. Just peek over it. As you guys are peeking over, does anybody have a part they specifically want to ask about? 3 through 6 on Saturday or Wednesday, so you need to get fed. Whenever you have an indefinite integral, so integral is no age. So always plus on any indefinite. Well, hopefully you make the same mistake. Okay, one more minute. It's something you take a special note of, then we're passing them back up to get them out of your lines and back into mine.
So you gave us 4 bonus points?
Yeah.
Is there any way?
There were 4 extra points built in. So I subtracted your score from 31 instead of 27. So subtract your score, like how many you missed from 31. Subtract how many you missed from 31. The first section was worth 1 point. All the formulas were worth a half point, and then the big old Mama Bahamas in the back were worth 2 points. All right, pass them up when you're done. Pass them up when you're done.
Yes, take 6 minutes.
Alright, 3 through 6, I want to look at mock AP questions if possible. Period 1 is looking at your video for help. Alright, where are we going now?
4A.
4A.
On Saturday.
On Saturday, thank you. 4A, on Saturday. You would give a name to this problem. What would you call it?
Area.
Alright. Yeah, I see a big old capital R, that's a good call. Area. Shouldn't area be easy? So why was it hard? Shouldn't area be easy? So why was it hard? You're supposed to find R, and if I were you, I would have thought about shading said R to give myself clear boundaries. When does R start and when does R stop? Do you guys agree with this and agree with that? Where is that starting and where is that stopping? I don't know. It's whenever this dude, who is my F, intersects this dude, who is 3. Whoa. You have to find it? Can you eyeball it and say, I think it's -1 and 1? Yeah? Would it be a lot safer if you actually went ahead and found the intersections instead of, hey, it's whenever these two collide? So you go ahead and multiply up and divide. I get 2 equals 1 plus x squared. Some of you guys were lucky that it did end up, in fact, being x equals plus or minus 1. So once we know that this region is bounded by plus or minus 1, all you need to think about is from -1 to 1, or from 0 to 1 doubled using symmetry. Who's on top is my function. And who's on bottom is 3. But the dilemma is, you were not just supposed to set up, write an integral, and not solve. You were supposed to find, which meant keep going. Guys, how do you integrate a 1 plus x squared in the denominator? Or an a squared plus u squared in the denominator? Isn't it going to be tangent inverse of x? A is 1, u is x. So 1 over a is 1 over 1. There's a 16 that's just chilling. In addition to all that, he could come out. He's a coefficient. Minus 3x, and my bounds are from -1 to 1.
Why is it 16?
Guys, change the 6 to a 16 for no apparent reason. Go team.
Wait, I think that was the bracket or something.
No.
Yeah, I think I was starting to draw something extra. But now we're okay, right? Plug in F. Some of you guys don't know your unit circle and you need to. Because at this point, 6 times tangent inverse of 1, that's 6 times pi over 4. Minus 3 times 1 is minus 3. Minus FTC, plug in a -1, that would be 6 times negative pi over 4. Minus 3 times -1 minus -3 is plus 3. The -3 minus 3. Wait a minute, hold on. Why on earth would I go any farther? Why did I have to get up to here? Because it said find, and I'm not done finding until I have a numeric expression. But why do I not have to go any further?
I understood that, but in the video, there was just like a 2 that appeared out of nowhere.
Oh, because they were trying to remind you of symmetry that you might see somewhere else on the test, that because the area on one side is the same as the area of the other, you could have just gone from 0 to 1 and doubled it, and then you wouldn't have had to plug in a -1. You could have plugged in a 0, which is actually easier. So all it has to do with symmetry. They're the same thing. Yeah.
It's fine leaving like the answers in a tan inverse. But do you want us to?
No. Use circle, go all the way. Yeah, use circle, go all the way. Yeah. Yeah, so number 4 is still on Saturday, right? Letter C is taking that same region, that same little R dude. Oh, just kidding. H is the vertical distance. Whenever you see vertical or horizontal distance, I want you to think either a Y or an X. Oh, X, f of X. Never mind, there's that function. We didn't even look at that graph. So we had F going here, we had 3 going here, and we had something like that, right? No, that's not right. Yeah, that is right. Where this is my Y equals 3, and this is my F, and this is my R. Okay. Let H be the vertical distance between the point X, go some arbitrary X, f of X. You can even go like graph an X, f of X. And the horizontal line, oh, they're just talking about this? So H is how high is your Y minus, it's just top minus bottom. Isn't that the vertical distance? Top minus bottom is how far? Then it says, find the rate of change, don't raise that up, with respect to X. So wouldn't that be dH dx is equal to f prime of X minus 0? And all I have to do is say, hey, let's plug in 2. So then plugging in 2, I would get my H prime of 2 is equal to F prime of 2. So I have to come back to F. Double check me, guys. I honestly, is it 6 over 1 plus X squared? I personally, just because I'm lazy and I like chain rule, I would have made this a negative 1 power so I didn't have to do quotient rule. But either way, it should have been legally the same thing. Bring down the negative 1. It's going to be a negative 2. But I can't forget my U prime. So then I would have plugged in my 2. Should I take it to regular? Saturday or Wednesday, 4 through 6. Sorry, 3 through 6. Saturday or Wednesday, 3 through 6. Saturday 5. You're going to give this guy a name. Who would you name him? Yeah, maybe differential equation because I see a dy dt. Maybe the chemical problem. It depends on whether you're more of a what's the application or more of what's the math kind of person. But yeah, differential equation problem. And you said B, right? B is so easy and hard. Now they give you a hint. Using the given differential equation, aka it's saying look at the differential equation, which is right up here, right? So I would have written them and been like, well, you told me to use them, so I'm going to think about it for a second and be like, why should this help me say this cannot possibly be the graph? This derivative tells me about whether y is increasing or decreasing, right? I see a negative, so I would say decreasing, but maybe it'll change. No, it won't. What's anything squared, guys? A positive, so guess what? dy dt. Will always be negative. Y is, if dy dt or y prime is always negative, what does that mean that y must always be doing? Must be strictly decreasing. I'm going to put a dot, 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 because what does this graph do? Start to increase. Has to only be going down. Has to only be going down. 3 through 6. Sorry, Saturday or Wednesday. 4D of 2018 Saturday. 4D. Oh, so when we just did, oh, there is a D? There's no D for 4. Do you mean 5D? Sorry.
Wow.
Oh my god.
Guys, shh. Look at the wording for 5D.
Determine whether the amount of the substance, which is Y, is increasing or is changing at an increasing or decreasing rate. Wait, who's increasing or decreasing? So I need the sign of rates prime. Oh, I need rates prime to know whether or not rate is increasing or decreasing. I look at the first derivative of whatever's increasing or decreasing. I'm trying to figure out. So, rate is dy dt, right, guys? I need his prime. Oh, so I need to find the second derivative. So I need to come back here and say dy dt is equal to, and I don't remember at all what it was. Was it negative? I need to take the derivative of this shebang. Which I'm going to do to both sides. I'm going to take the derivative of this guy. I'm going to get negative 0.02 times dy dt. Wait a minute. Don't we know who dy dt is? You just told me who it was?
I think it's squared.
Oh, is it squared? Sorry, I just didn't remember. Just kidding. So bring down the 2 and then I make that a y. And then that's going to be times 2. Which should be 0.04 y times dy dt is negative 0.02 y squared. Pause and check it. I have a negative times a negative, which is a positive, and I have a y that will only ever be positive. We're talking about how much substance is there. Therefore, I can say the second derivative is always positive. The second derivative is positive. The rate's derivative is positive, which means steal their words and sound amazingly smart. Bye, guys. We might have a little bit of time after the forever final tomorrow to go over extra questions, but not a lot. We pause the video.